Okay, in this video we go through worked solutions for relationships in Calculus Assessment Standard 1.4. The first question here is an integration question, and before you can attempt integration you need to prepare this function. That means removing any square root signs or radicals and writing everything in the form ax to the n. So square root of x can be written as x to the half, and the second term is actually all ready to be integrated. Now the whole function should be in brackets, and don't forget the dx, that's crucial. One more step then, bringing the x to the half up to the numerator gives us an integral of x to the minus half plus 5x to the minus 2. Still in brackets, all with respect to x. Now we can integrate here by adding 1 to the index, so x to the minus half becomes x to the half, and dividing by that new index. The same on this term, add 1 to the index, gives us 5x to the minus 1, and all of that divided by minus 1. Now there are no limits on this integration, so we must remember to add on the constant of integration. And of course we'll go one step further here, because x to the half can be written as root x, and dividing something by a half is the same as multiplying it by 2. Similarly over here we've got 5x to the minus 1 divided by minus 1. That will make this whole second term negative, and x to the minus 1 can move back down to the denominator. Notice that the 5 stays at the top, and we now have 5 over x plus that constant. It's important that you fully simplify these fractions. Leaving it as divided by a half isn't good enough. Also leaving divided by negative 1, that's not fully simplified, so make sure you get into the habit of taking it to that final stage. Question 2 here. Just take a moment to realise that you've been given g dash of x. That means that somebody has already differentiated g of x to come to this result, and you've been asked to find g of x, which means you need to go backwards. Anti-differentiation, which is also known as integration. So the first thing to do here would be to say that you know that to get g of x we need to integrate 3 take x to the 5. Again, don't forget the dx, that differential there, very important part of the integral. Now this thing is ready to integrate, but you should notice that it's a composite function. 3 minus x, that linear function in the bracket there, is a function itself, and then this raising to the power of 5 is another function. So integrating here using the chain rule for integration gives us 3 take x, add 1 to that index. We'll need to divide by the new index, but also dividing by the derivative of this inner function, and in this case the derivative of the inner function is negative 1. We don't have any limits, so we add the constant of integration. Again, this thing isn't quite fully simplified yet. It becomes minus 3 take x to the 6, all divided by 6, plus the constant. And that's the end of the road for that one. On to question 3. We're integrating a trig term. Now you have a formula sheet with some standard integrals on it, although I would certainly suggest you think about trying to remember this little diagram if you haven't seen it before. What happens here, if you go clockwise round this diagram, this is the trig derivatives. So sine, derivative of sine is cosine, derivative of cosine is minus sine, derivative of minus sine is minus cos, and differentiating minus cos gets you back to sine. So differentiating clockwise and integrating, or anti-differentiation, anti-clockwise. So in this case we've got a negative cos term, differentiating negative cos, going anti-clockwise around this relationship here takes us to negative sine. So integral of negative 2 cos t is negative 2 sine t, again no limits, So we need to add the constant of integration. And question 4 here for 4 marks. Quite a bit of work. It's a definite integral. We have some limits, which means we'll eventually get a numerical answer at the end of this. The function itself is ready to integrate. We just need to be aware that it is a chain rule for integration. So this will become 4 take x, add 1 to the index, takes it up to 4, dividing by that new index, and also dividing by the derivative of that inner function of 4 minus x, the derivative of 4 minus x. That just leaves you with minus 1. No need to add a constant here because we have got these limits, which we're going to have to substitute in. Before we do that though, I would recommend that you simplify this as far as you can. So 4 take x to the 4 all divided by 4, and this negative 1 that was on the denominator would make that whole thing negative, and this would be between the limits of negative 1 and 3. So the next step here will be to substitute in the limits. Upper limit first. We're going to have negative 4 take 3 raised to the 4th power over 4 minus, and then we'll substitute in the second limit, which is negative 1. So just be careful with the signs, put in as many brackets as you need to make it clear what's happening here. 4 take negative 1 to the 4 all divided by 4, and then we can start to evaluate this stuff. 4 take 3 is 1, 1 raised to the 4th power is 1, so we've got negative a quarter in that first bracket, and from that we're going to subtract the result of this second bracket. Now 4 take negative 1 is of course 4 plus 1, which gives us 5, so we've got 5 to the 4 all over 4. Let's don't forget there was that negative sign at the start there. And you're allowed a calculator for this assessment, but 5 to the 4 is something you might be able to work out. I'll just show you this at the side here. 5 to the 4 is of course 5 squared multiplied by 5 squared, which is 25 plus 25 or 25 squared. And an interesting little trick maybe, any number that ends in 5, it's very easy to square it. All you need to do is examine the digits in front of 5, in this case it's just a 2, but any of the digits in front of 5, take that digit and multiply it by that digit plus 1, so not 2 times 2, but 2 multiplied by 3, which gives you 6, 2 multiplied by 3 gives you 6, and then add a 25 at the end. And that's the way to square any number that ends in 5. Examine the digits in front of the 5, multiply it by the number which comes after it, and then add 25 to the end. So back into this main body of the working here. 5 to the 4 we've just decided is 625, which we don't lose a negative sign here, all over 4. Negative a quarter, take away negative 625 quarters, so basically this turns out to be 624 quarters, which does divide by 4, and again you've got a calculator, but you might even be able to do this in your head. 624, 625, you might be able to do this in your head or set out some working for it if it's in a non-calculator paper. Carry a 2 into here, gives us a 5, and 2 carries into the 24 to give us 6. So the answer to this definite integral, 156.